Good evening, everyone. Here's another follow-up on my progress with experimenting with the Minimig core, adding elements one by one, and just kind of going through the same explanation and same paradigm of this design that maybe will make some sense to some of you guys who are asking me questions recently in the last few days. So the first question was that there is so many things going on. I'm experimenting with this edge board, doing the RTL development. Also, I'm working on Mystex board, experimenting with that. Then I have this main thing, which is effectively AmiCube board, which is the goal of all this. Let me just bring it in so I can show you that. Here's the AmiCube board, the one that's going to be the final destination. Sorry for the dust. I haven't been playing with this for a while, but effectively this is a functional board. It's a Spartan 6, level shifters, good old SAM S7 running a Minimig core, SRAM, floppy drive headers. I have a module that's well integrated and working fine, and the CPU here. PyStorm, original CPU, Terrible Fire, all works fine. So what's going on? Why am I working on so many things at the same time, and where are we going with all this? Like, what's the goal and what's the status? I mean, maybe I should clarify a little bit steps here. So first of all, this is the goal. This is what I'm working on. Unfortunately, when I designed this board, I used slightly older part, which is Spartan 6. This is comparable to Spartan 7. There are slight differences here, but the problem is between Spartan 6 and Spartan 7, Xilinx decided to introduce a new development environment. So this is the old school ISC development environment, and if you move to 7th generation, it's a brand new Vivado, which is much better piece of software for just doing overall development. It's faster, it has better algorithms for the optimization, it's better to use integrated logic analyzer. It's much easier, more precise, faster. It's much better tool. So for me to use this chip, I was thinking I can reuse old Minimig code and environment, and might be easier for me to implement stuff. That was a mistake. So what I'm trying to do now, I may still use this board for some sort of RTL development, because, you know, Verilog is Verilog, doesn't really matter. Just might be a little bit more difficult to do the test bench and logic analyzer and timing. But the thing is, we need to move to 7th generation. So therefore, this is coming to the play. This is the 7th generation board. It's running Minimig. And I already have some very important building blocks. So I have the part in hardware, in schematics, and in modules that's actually dealing with this modularity. So I can attach USB stuff, I can attach serial, I can attach DB9 joysticks, PS2, and you know, I'm now treating Minimig as a puzzle, as a Lego bricks. So I want to have clean code for every single modular piece. So no matter what kind of I/O you need, you can just attach it to the board. So that's the whole idea, right? So the board will have these something that will look like ISC card or something like that, ISA card, for example, and you'll just attach your board, and you'll have your I/O, desired I/O, right? In some cases, if the board is large enough, you'll have everything already on board. If you don't, I may just add kind of like a P mode, but more like a ESA slot, right? That sort of thing. So that's the goal. And lo and behold, this is working. Not just that it's working fine, this is AGA core. It's also running a virtual I should say not virtual, but rather a soft core for replacement of SAM S7. So as you can see, there's no more of that sort of missed Minimig, original Minimig controller on board. that does the loading the FPGA and provides SPI communication with SD card and this and that. So that's all in softcore. Phenomenal stuff. Now I also want to be upfront. There is still more things to do. The performance is not ideal for the SPI. I need to improve that. It's kind of sluggish. But aside from that, everything else, timing for the RAM is great. I can add more RAM. Now it's 32 megs, but I can add more. That's easy. VGA is working in parallel with HDMI. I need to confirm the USB design, which I already have. That will be great. Finally, you can choose between old school PS2 DB9 and for joysticks, and like pure USB for your peripherals. Fantastic. You can use wireless mouse, keyboard, and this whole thing can be attached behind the TV, VESA mountable, and you'll have your Amiga completely unintrusive somewhere in your gaming room or in the hotel when you're traveling or whatever you need. So that's fantastic. So all of this is a proof of concept for the common goal, which is AmiCube. I'm not really trying to make 100 different things. Although I'm just going to disprove what I said in a small way, but I'll going to admit it's in a small way, and it's in also a constructive way. But this is it. This is migration to Vivado, and make sure that we are up to date and we use modern parts. No matter if it's Spartan or Artix or Kintex or whatever, it's all cross-portable. FPGA is FPGA, and we'll be able to use all these parts. Somehow I landed up on Xilinx. Not to say that Intel or Altera Cyclone are any better or worse. They're equally good. Even Lattice, I think, and other companies. I think there is another one called Trion. That one is also really good. There's nothing wrong with these parts. It's just that Xilinx is quite popular, and most of the engineers here in Canada and in the world will introduce Xilinx as a benchmark. Having said that, there is also a price to be paid regarding the price of the parts. Xilinx parts tend to be more pricey, but the quality is there. The overall tools for the timing and also the part itself, it's top notch. It's leading in the industry. It's great. Again, not to say the other parts are not. They're fantastic. Altera is also top end. But I mean, you need to choose something, I guess. And this is something that was a beginning of the whole Minimig and Mist development. Actually, Minimig Mist not so much. Mist started from Cyclone 3, I believe. But either way, let me show you where we are with all this. I have some cool things to show you, or rather one thing that you haven't seen before. So maybe let's start from what you've seen before, and that's HDMI. So HDMI is working fine in parallel with the VGA. So you can see it's the same thing, right? But what's really cool about HDMI is that I can do those screen resizes. So let's say I want to play a game no matter what it is. Maybe this one, let's say Shadow of the Beast. It will start loading. And what you will notice is that most of the time the game is actually not covering the entire screen. So this is something that I showed last time. So you can actually rescale the output. You cannot change the resolution of Amiga. Amiga will always output what it outputs using its chipset, right? But what you can do, you can actually change the top layer resolution that FPGA is using to produce the signal, right? So, for example, in this case, if we press print screen, or actually now it's wired to scroll lock, it will zoom in. So I can get games to be really from edge to edge, which is kind of cool. But this is not new. I already showed this before, and I'm trying to exit now this thing. There you go. So that's nothing new, and this is how it looks like. Typically you wouldn't do this in Workbench because you would just cut off your Workbench screen, but in the games where the visible area it's smaller than the entire screen, this is fantastic. You can really enjoy some games in the full screen. One of my favorite examples actually is that demonstrates pretty well. It's BAT game from Ubisoft, one of my favorite Amiga games. Although this is also released for DOS and many other platforms, but it's quite a cool game. So if you take a look now, you'll see where the output is. So if I press scroll lock, it should come closer, and then again, I'm just reducing the resolution now 4 times. Okay, now I have the lucky resolution that actually fills up entire screen. So when you play the game, you have this tall full screen experience, and it's not emulation, it's hardware wise, it's, you know, going from FPGA that does as close as possible cycle exact thing. It's Bob's your uncle. This is beautiful. Okay, but having said that, I'm not doing that yet at the VGA, so you need to change that. And the other thing is, going back to HDMI, I'm using this kind of like fake DVI-over-HDMI. I'm not really using HDMI, so I don't have sound excuse me, going from the same cable, HDMI cable. So I need to implement proper HDMI and do this. I don't know about the licensing and all that sort of things, IPs, I need to look into that, but right now, I mean, even though it's using HDMI cable, this is not really HDMI, this is DVI, right? So this is place for the improvement. I'm just telling you what's next in terms of improving the code. So needs to be HDMI, needs to have the sound, and this thing also needs to have rescaling. So we can rescale VGA and you know, do the same Blackmagic thing that can zoom in. Why having this black bezel? There's no reason. If we can do that on HDMI, having a full screen, we should do that on the VGA, right? Okay, so let me try to exit this thing. I never know with this HDMI load, what's the exit button, because every time is different. So I'm just maybe going to restart. Why not? Let's reset. And then I can go through to demonstrate the next thing, which is retargetable graphics. So this is something that was ported on the Minimig some time ago, and what it is actually, it's the way of introducing the real graphics card on the Minimig. So there was a time in Amiga history where you can get these, I don't know, usually it was Cirrus Logic or S3, graphics cards, very similar to PC had back then. You can attach that to Zorro slot, and lo and behold, you would get these, high resolution graphics, frame buffers, whatnot, to just run software in high resolution, do the productivity stuff, run, image design software, rendering, whatever. It was a great thing, having a graphics card for the Amiga. Now, because we have this additional space on FPGA, people figure out how to squeeze in the whole freaking thing, the whole graphics card inside of the FPGA. So you can load the module, you can load the drivers, and boom. So what I mean by boom, you can see here, this is freaking amazing. So the Workbench is in high resolution. This is, let's see what this is. Let's see which resolution is this. I've set it up when you reboot, goes there. 800 by 600, but you can go crazy. You can go all the way to 1280 by 1024 on the Mister, because it has, I think, more RAM, and also implementation is slightly different. I think you can even go full HD 1080. So that's beautiful. You connect your thing to HDMI and you have this like really high resolution. So these are the hodgepodge pieces of code I want to implement into this next generation AmiCube Minimig board. So we have that sort of high-end thing. But for the screen like this, 800-600 in true color is perfect. And you see, I mean, this looks great, looks phenomenal. You can see my SPI here is not really performing well. I think it's half of the speed what is supposed to be on Minimig. And I think we can probably quadruple this performance just by looking at the timing and looking at the implementation. I don't know if the bottleneck is 832 soft core right now. I need to check, but this is another thing that I need to work. So there is this Excel table where I'm putting, you know, things that I need to put the check mark on because we have a formidable little Amiga package ready for release. So many people are asking me about this RTG. Will this impact the Amiga games? Old school Amiga chipset games will not be impacted. It's the same. You can still run these games directly from here. It will work just fine. But there are RTG games for Amiga. They're using this, another layer of graphics, which is effectively like you having a Picasso card inserted into your real Amiga. And you can play these games. Now, depending on the amount of performance, once this is ready and once we have a CPU socket and you add PyStorm, man, that's going to be amazing. You'll have RTG coming from chipset, I mean from FPGA, you'll have your PyStorm just crunching the numbers, and you know, Duke Nukem, Quake, all those things will just fly. So that's fantastic. So there you go, RTG is done. That was another milestone. Implementing the modules or the pieces of Verilog code wasn't difficult. What was difficult is figuring out which drivers I need to use for RTG, because this particular implementation has its own particular driver. I didn't know that. I was trying MIST and MISTER drivers and it didn't work, and then I found in the code, I did find a driver specifically for this approach for 832. By the way, I'm using a lot of components here from some previous Minimig projects. It's a hodgepodge of many things I could find. I try to optimize code, change the code, contribute something to it. I just hate just reusing what other people did. Whenever I can, I make something better. And of course, in the same sort of paradigm or the same sort of tradition, everything in the source will be open source, as it should be for Amiga and Minimig, and that tradition will continue with everything that I'm doing, bringing back advancements to community. Okay, so that's that. Again, don't focus on this. This is just a development. We're focusing on this. So what this is going to be is going to be 7th generation here. SRAM will be most probably replaced by, not most probably, certainly will be replaced with the next gen of SDRAM, the chips that we are using for MIST and MISTER. So it's going to be 32-bit. Why? Because this is 16-bit RAM, we don't have enough oomph to do the AGA. You can do 16-bit AGA, but you need speed. Speed is what you need, because we, even though we have 16-bit architecture, we're doing 32-bit kind of performance, right? So that's these chips are no-go. That's why I was struggling so much to port AGA here. Didn't work out because of simply the bandwidth, the oomph of a bus. So that will be replaced as well. Now, this is just a tangent. It's a little bit of tangential topic, and me just brainstorming. I think these Minimig systems that I'm going to build, I'm going to leave a lot of ports and a lot of options for it. I want to keep, even though if we decide to go fully soft core, it would be fantastic if I can keep ARM as well as a legacy thing, so developers can use that in any sort of capacity. These ARM microcontrollers can be replaced by modern parts, so it's also important that this is not stuck on board, that it is connected using some sort of connector that's good enough in terms of you know, impedance and characteristics, so we can attach better parts and do that. But this will be an option, so people can do proper development, port code from it, and this and that. Because I mean, the whole idea of these boards, it's not just to be a board for playing games, but rather development open system where people can attach stuff, you know, and do all sorts of development. So that's, I hope that clarifies some of the questions you have about, like, why are you dealing with all this other crap? Of course, I mean, you know, focus on one board, for God's sake. But the thing is, it is about one board. It is about having just enough of developmental code, bits and pieces, because if you look at these things, they're so multidisciplinary. You're looking at the hardware development, so you're looking at this physical layer of, you know, resistors, LEDs, level shifters, RAM, timing. Then on top of that, you're looking at the firmware. So firmware has a very important role. If you consider MIST, MISTER, and Minimig, those are all siblings. Started from Minimig, and then MIST was the firmware was built on the top of Minimig. So it's not a unique invention. It's improved version of Minimig firmware. And then on the top of that, we have MISTER, and I was shocked recently to realize this and talking to Hans, that even MISTER is actually the core firmware is coming from Minimig. So Minimig actually kickstarted this kind of revolution of us playing with these FPGA retro computers, which is great. I'm really happy to know that. Of course, MISTER has much more on the top of that, but that's a great legacy to have. And what I'm trying to say is that I think this multidisciplinary approach goes from not just the firmware, but also on the top of that, it's RTL and FPGA. So you're going hardware design, firmware design, and effectively RTL or chip design. So you can go, I mean, further than that in computer science. It's difficult. But to kind of get all that together, you need to have this approach where you understand the modularity of it. You know, what is the module? What is the common denominator piece of hardware that's actually present an interface or a port? Or so to kind of figure that out, I think we need to use development boards extensively to have all these pieces separated, and then ability to port these pieces to different architectures, different boards, and just reuse that code, right? And reuse the design. This PMOD is a great example. I'm not saying that PMOD should be production ready for the board. I think board should have something better. I aforementioned the ISA slots or whatever, some sort of proprietary, not proprietary, but Minimig or FPGA specific port. But what I'm saying, this PMOD can go to any development board, and it can provide connectivity. If you use the Verilog module, it can provide connectivity with the Minimig. So I'm trying to separate these parts, and then at that point, once I have good understanding of this is the hardware common denominator, this is the module common denominator, I can port it easily to different chips, to different boards, and so forth. So I think this should be the goal. It's not creating one board, but rather creating these hardware RTL siblings or pairs, and make them portable and understand them well in terms of timing and how in terms of design and so forth. So this is the whole thing. I hope this sheds a little bit of light at the whole process. And again, people are asking me how much time you'll need until this is ready. Really depends how many people are helping. Right now I'm working this mostly alone. I had help with someone from time to time, but at this time, you know, maybe it wouldn't be a bad idea to kind of get someone to join the team and start working on these things. If you're watching this, if you are a FPGA developer, let me know. Give me a call, send me an email. You can always send me an email to my first name at minimig.ca or office@minimig.ca, and I will reply if you're interested in joining. As a hobby project, that's fantastic. If you're interested in joining as a, some sort of commercial endeavor on the side, I have a small budget that I'm putting on the side for development, so that's also an option. So you can, earn some money if you like playing with this, even though it's an open source. It's my way of contributing back to community. So yeah, keep that in mind. The only thing is, in the past, I've been talking to people about development, and then pretty quickly I'm realizing I know about 75 times more about this stuff and development than the guy who is pitching for the job. So don't take this lightly. If you understand, if you're a real developer, if you have not a real developer, there's no such a thing, but I mean if you have real experience, hands-on experience, and if you just plow through the design and code and build stuff, let me know. I'm actually open to bring someone on board and as a contributor or as a contractor who can actually work on this maybe even long term. So that's that. As you can see, I'm quite committed to get this to the finishing point. All the bits and pieces are here now. It's a matter of integrating and polishing off all these little things about the software functionality, excuse me, modularity, about design and so forth. So this makes long-term more sense. So many times I've been cutting the corners, making stuff easier for me, like using the older part, this and that. That needs to stop. Now we need to make sure that proper engineering approach is applied here in terms of longevity of the parts, end of life of the parts, how easy it is to change the system, add new components and this and that. So overall, I can tell you I'm happy. Progress is made all the time. You need to understand we all have our real jobs. This is in a hobby domain. Even though I'm making and selling these boards online, this is not really bringing any profit. It's more of me to pay off the parts for the development and help me with the prototyping. Nothing more than that. So, but it's a labor of love, like for all of us. So that's my long monologue about all this. Hopefully this video brings some light on where is this going, and just to keep everyone's how can I say that, everyone on the same page. We are on board with this, like working on the design daily. So anyhow, with this beautiful retargetable graphics screen, I'm leaving you there, and I will keep you posted about the progress. By the way, side note, when it comes to mistakes, my previous video, I'm still going back and forth with Hans. Unfortunately, I cannot load the core. I have seems like SPI corruptions. I blame Orange Pi, which seems to me good product, but a crappy product, because not every board can boot. The firmware differences are there. I think there's something going on with this SPI line. Unless I have a wrong resistor somewhere on the board or something stupid like that. I did check, I couldn't find it. So far I'm putting mistakes on standby. If I get some information from the community or from Hans, I'll give it another try. I'll test whatever I can. I don't think I'll be able to debug SPI at the moment because of all this stuff that I'm working on. But when I have time, I'll definitely join the efforts and try to figure it out. I think that Mystex needs something better for its controller part, maybe some high performance modular ARM system on the chip thing that's easier to integrate on board, and that's more standard, I think, and maybe something that's using less of a Linux, more of a bare metal, or maybe very small embedded Linux that has, you know, just kind of that thing that runs emu68, right? Something that can boot in a second and just, you know, kickstart the entire thing, bare bone, super light, and, you know, that sort of thing. But long story short, as of now, I cannot boot Mystex, and I'm still trying to figure out why. At some point, if I have any sort of revelation, I'll let you know. There is another project that will come pretty soon. Now I'm actually going against myself saying that. I'm saying that I'm not working on multiple projects, but I do actually. There is one thing that I've been working for a while. And it's getting close of being done, or rather it's getting close of me start routing the board, and that will be a big freaking deal. It will be a great board. It's not going to be AmiCube per se, but it will be something that will make a big difference. So stay tuned for that as well. I'll keep you posted, but for now that's it. That's all I need, all I have to say. And as always, hopefully every single development cycle and every single step forward, I'll let you guys know what's going on. And okay, it's about time to stop the video, and talk to you soon. Thank you. Bye bye.